Hello students, welcome to InstaOut's science class where we believe in democratizing education for all. In the previous sessions, we covered the theoretical concepts of the topic electricity. Now, we will apply those concepts by solving a variety of numericals and strengthening our understanding through practical problems. To start, let us now solve a numerical based on the concept of electric charge. The problem states, a filament of an electric bulb draws a current of 0.4 amperes for 5 minutes. We are required to calculate the amount of electric charge flowing through the circuit. To begin with, the first step, we identify the given values. The current I is given as 0.4 amperes and the time t is given as 5 minutes. Since time must be in seconds for our calculation, we convert 5 minutes into seconds. That is 5 into 60, giving us 300 seconds. Now, in step 2, we recall the formula for electric charge. According to the definition, electric charge Q is equal to the product of current and time. This gives us the equation Q is equal to I into T. Substituting the given values into this formula, we get Q is equal to 0.4 into 300, which results in Q is equal to 120 coulombs. Therefore, the amount of electric charge that flows through the circuit is 120 coulombs. Let us now solve the second numerical step by step. The problem states, calculate the work done in moving a charge of 2 coulombs across 2 points with a potential difference of 10 volts. In the first step, we identify the given values from the question. The charge Q is equal to 2 coulombs and the potential difference V is equal to 10 volts. In the second step, we recall the formula for calculating work done in an electric circuit. According to the definition, work done is equal to the product of the charge and potential difference. Mathematically, this is written as W is equal to Q into V. Proceeding to step 3, we substitute the given values into the formula for work done. Using the equation W equals Q multiplied by V and substituting Q as 2 coulombs and V as 10 volts, we get W is equal to 2 into 10, which gives us the result as 20 joules. Hence, the work done in moving the charge of 2 coulombs through a potential difference of 10 volts is 20 joules. Let us now move on to numerical 3, where we are asked to calculate the current drawn by an electric bulb when connected to a 200 volt source, given that the resistance of the bulb filament is 1000 ohms. To solve this, we will follow a structured approach step by step. In step 1, we identify the given values. The voltage V across the bulb is given as 200 volts and the resistance R of the filament is 1000 ohms. Proceeding to step 2, we apply Ohm's law, which relates current to voltage and resistance. According to Ohm's law, the formula is I equals V divided by R. In step 3, we substitute the known values into the formula. That is, I equals 200 volts divided by 1000 ohms. Now, in step 4, we calculate the result. Performing the division gives us I equals 0.2 amperes. Thus, the final answer is that the electric bulb draws a current of 0.2 amperes from a 200 volt source. Let us now solve the fourth numerical, which closely follows the same pattern as the previous one. The question here is to calculate the current drawn by an electric heater coil from a 200 volt source when the resistance of the heater coil is 100 ohms. We begin with step 1. identifying the given values. The voltage supplied V is 200 volts and the resistance of the heater coil R is 100 ohms. In step 2, we apply Ohm's law, which states that the current I is equal to the voltage V divided by the resistance R. That is, I is equal to V divided by R. Proceeding to step 3, we substitute the given values into the formula. So, I is equal to 200 divided by 100. In step 4, we carry out the division. Dividing 200 by 100 gives us the value of the current as 2 amperes. Hence, the final answer is that the electric heater coil will draw a current of 2 amperes from a 200 volt source. Let us now solve the fifth numerical by breaking it down into clear and complete steps. The question states, the potential difference between the terminals of an electric heater is 50 volts when it draws a current of 2 amperes. What current will the heater draw if the potential difference is increased to 120 volts? We begin with step 1, where we identify the values given for the initial condition. The initial voltage across the heater is 50 volts and the corresponding current is 2 amperes. In step 2, we use Ohm's law to calculate the resistance of the heater. The formula for resistance is resistance equals voltage divided by current. Step 3 involves substituting these values into the formula. So, resistance equals 50 divided by 2, which gives us the value 25. Step 4 confirms this result. The resistance of the heater is 25 ohms. Now we proceed to the second part of the problem, where the potential difference is increased. In step 5, we identify the new value of voltage, which is 120 volts. In step 6, we again apply Ohm's law, this time to calculate the new current. The formula is current equals voltage divided by resistance. Step 7 involves substituting the known values. Current is equal to 120 volts divided by 25 ohms. In step 8, we calculate this expression. 120 divided by 25 gives us 4.8 amperes. Therefore, the final answer is the heater will draw a current of 4.8 amperes when the potential difference is increased to 120 volts. Let us now solve a numerical based on the concept of resistivity. The question states, calculate the resistivity of a metal wire at 18 degrees Celsius given that the resistance of the wire is 27 ohms. Its length is 1 meter and its diameter is 0.2 millimeters. To begin with, in step 1, we identify the given values. The resistance R is 27 ohms, the length L is 1 meter and the diameter D is 0.2 millimeters. Since the unit of length is in meters, we must convert the diameter into meters as well. Thus, 0.2 millimeters becomes 0.2 multiplied by 10 to the power of -3 meters. Proceeding to step 2, we calculate the radius of the wire. The radius R is equal to diameter divided by 2, which gives us 0.1 multiplied by 10 to the power of -3 meters. In step 3, we determine the cross-sectional area A of the wire using the formula for the area of circle, which is A equals pi r squared. Substituting the values, we have A equal to 3.14 multiplied by square of 0.1 multiplied by 10 to the power of -3. This results in an area of 3.14 multiplied by 10 to the power of minus 8 square meters. Moving to step 4, we now use the formula for resistivity. The formula is rho is equal to R multiplied by A divided by L, where rho is resistivity, R is resistance, A is area and L is length. In step 5, we substitute the values into the formula. Resistivity denoted by rho is equal to 27 ohms multiplied by 3.14 multiplied by 10 to the power of minus 8, all divided by 1 meter. Finally, in step 6, we calculate the result. The product of 27 and 3.14 gives us 84.78. So, the resistivity is 84.78 multiplied by 10 to the power of minus 8 ohm meter. Therefore, the resistivity of the metal at 18 degrees Celsius is 84.78 into 10 raised to the power of minus 8 ohm meter. Let us now solve the 7th numerical based on the concept of series combination. The question states, an electric lamp with a resistance of 10 ohms and a conductor with a resistance of 2 ohms are connected to a 5-volt battery. We are asked to calculate 3 things. First, the total resistance of the circuit. Second, the current flowing through the circuit. And third, the potential difference across both the lamp and the conductor. To begin with part A, let us calculate the total resistance. In a series connection, the total resistance is the sum of the individual resistances. The resistance of the lamp is given as 10 ohms and the resistance of the conductor is 2 ohms. Therefore, the total resistance denoted by R total is equal to R1 plus R2, which is 10 plus 2, resulting in 12 ohms. Now, moving to part B, let us calculate the current flowing through the circuit using Ohm's law. According to Ohm's law, current I is equal to the voltage V divided by the total resistance R total. Here, the voltage provided by the battery is 5 volts and the total resistance we just calculated is 12 ohms. Substituting the values, I is equal to 5 divided by 12, which gives us approximately 0.417 amperes. Let us now proceed to part C, where we calculate the potential difference across both the lamp and the conductor. First, to find the potential difference across the lamp, we again apply Ohm's law in the form V1 equals I multiplied by R1. Substituting the values, V1 is equal to 0.417 amperes multiplied by 10 ohms, giving a result of 4.17 volts. Next, we calculate the potential difference across the conductor using the expression V2 equals I multiplied by R2. The current remains the same, that is 0.417 amperes, and R2 is 2 ohms. Thus, V2 is equal to 0.417 multiplied by 2, which is approximately 0.83 volts. To conclude, the total resistance of the circuit is 12 ohms, the current flowing through the circuit is approximately 0.417 amperes, the potential difference across the electric lamp is 4.17 volts, and the potential difference across the conductor is 0.83 volts. Let us now recap what we have learned using our Insta Lights. We started with electric charge, learning how to calculate the total charge using the formula total charge equals to current multiplied by time. Then we moved to electric current, where we applied Ohm's law using I is equal to voltage divided by resistance to solve for current in various circuits. We also covered resistance in series using the appropriate formulas to calculate total resistance in both arrangements and understand their effect on current and voltage. With this, we have come to an end of the topic electricity. Keep watching our InstaOwl videos for further topics from science. Thank you and goodbye.